Hello, everyone. Thank you for coming today. This talk will be, and the reason why it was interesting to me is that I'm a sort of computer history buff. And I do a lot of research on the side, like on things that happen in software through the years. And one thing that in this talk really struck my imagination is that, if you think about it, like the PC revolution, I believe, was really kicked by the spreadsheet. And the spreadsheet hasn't really changed that much in all these, I'd say, 30 years or so. And Mr. Srblich's talk deals with the spreadsheet as a new metaphor for users in organizing services. And not only services, I would say, but more generally organizing data on the web and giving users a tool which they could use to organize those and give some semantic meaning to some of the things that are in the web, and that we are trying sometimes to deep crawl and gather what they mean, but sometimes we're not so successful in doing that. So I'm going to leave you with Professor Srblić, who will give you this lecture, and please give him a hand. Thank you.
Thank you very much. Since Boris introduced me, it's my turn to introduce the rest of the team, young colleagues which are working with me on this project. And although it's my second visit and second talk at Google, some of these younger guys have much more experience with Google than myself. Ivan spent a couple of months here working as summer intern, and Miroslav and Daniel, they are sitting over here. They are winter interns, working with Google nowadays here. So these are people who are working with me. First of all, from my experience, it's very important, let's say, a good sense of humor based on analogy of situation is very important for success on the project. And it's very important for creativity. Here, one of such analogy which came up during this research was about Pinocchio and Geppetto, his father Geppetto, and it so amused us, so I want to share this with you to make this presentation more interesting. And some of these fragments from this story we will use to make this presentation more picturesque. As our main motivation is that we think that human intelligence is very important in the process of composing web services into the composing services to web processes. Although all other research is going another way, they are working on semantic web, and they're working on the process of automation of composing these services into the web processes. We think that we want to build a tool which will be appropriate for end user to build web processes by composing these services. But the question is that it's a very tough challenge. Why? Because we, as we already know, that what is facing nowadays software industry when we are talking about multi-core processors. We know that processes which are inherently distributed and parallel, it's very difficult even for professional programmers which have formal education in parallel programming to build such processes. Here we are faced with the end users which actually do not have experience even in some basic programming, and we must build a tool which will be appropriate for them to build web processes which are highly distributed there and in parallel in their nature. So when we think about that, and a year ago when we have talked here, we find out that what we called before simple service composition language, which is script language, and even this language could be very tough for these users. So we think what should be the environment look like that these end users can program these processes. So we think that spreadsheet and gadgets, and we mix up these two things, you can build an environment, design environment, which could be very nice for use for end users. So I will talk about idea what and how you can mesh up the gadgets and spreadsheet and build such kind of environment. Next, in my part of presentation, I will talk about what is behind that gadget composition. And we will talk a spreadsheet-oriented execution environment, which is based on service-oriented architecture. And what kind of architecture we should use. As we find out that mostly service-oriented architecture are not appropriate for a very large or scalable environment, and how should we change that service composition architecture to fit our demands for efficient execution of such gadget composition or web processes. At the end of the presentation, the best way will be to conclude this presentation about new possible business models based on gadget composition. So all of us know that internet, wireless networks, sensor networks, mobile ad hoc networks are converging into the unified communication and service infrastructure. And that through virtualization, we will be able to control different kind of appliances, use different kind of services like this one, which we'll use in this presentation as example. And probably this virtualization will affect all human activities very soon, and which will force the end user to combine existing services and processes in order to create personalized composite processes. But we face the challenge how these inherently distributed and concurrent processes should be, designed. And question is, what kind of user interface we should use? What kind of programming environment? What kind of distributed architecture and distributed technology? So we find out that maybe gadgets will be the answer for user interfaces. Maybe spreadsheets will be the appropriate programming environment, which is widely accepted from end users. And we think that service-oriented architecture and web services are technology which will enable composability and interoperability of such distributed processes. What I will talk about is Geppetto. We call that, it's come from gadget composition programming tool. That will be our vision how this design environment should look like. How the programming environment, that is HUSKY, it is another analogy. It's about HUSKY dogs which are tied together to drag the sledge. So the services are tied together to construct new, to enable new functionality. So that is our environment for execution of services. Don't think about services like web services. Think about services as basic components from which you build your own application. Web services are just technology which are used to be interoperable. At the end, this stands for uncoupled service composition architecture. It is our, we define new, very efficient composition architecture in order to execute this gadget composition. Okay, so first of all, let me explain what we think about what means gadget compositions. Just imagine we are going to some content personalized page like which personalization we perform is through selection of gadgets. Let's say, for example, a Google personalized homepage, and then you go to the directory, and then you can find there a lot of gadgets. And let's imagine that we have two gadgets, which we'll use here for bookstore and for different bookstore gadgets. So you can use these bookstore gadgets, and you can choose another one, which will allow you to answer the question, which will be the best offer from these two bookstores. So how it works, you just type in the titles of the books, you get the price, from another bookstore and from another. And then you retype these offers, and you can calculate the best offer. Here we see that this is not convenient for use because you type all of this. You twice type the title, you press the free start buttons, and it takes a huge time. So question is, can we arrange these free gadgets in just one gadget and perform that as a one gadget and build a new gadget as a composition of existing gadgets? That is the main idea. So what we think that you can have a one, we call that blank gadget. We call that Pinocchio. It does not have any inputs or outputs, does not have any logic behind that. It just is blank gadget. Now you should define a new gadget as composition of existing one. So how can you do it? First of all, you must define interfaces. So what are inputs and outputs of the gadget? It's the analogy like, Geppetto starts from pile of wooden parts and assembled, Pinocchio. We start from blank gadgets, gadget and some existing gadgets and build new gadget. So first of all, we will put the name of the gadget, and then by using drag and drop, we can put input as a book title, best offer as result, and what will be the start button. Okay, now we defined what will be the input and output and how you start the gadget, but you needn't define how that gadget will work. So what we need as a second and the third step to define is to define a sequence of events, what will be performed during the execution of this, get best offer, event. And we must define the data flow, how this data flow, coming back and forward between these three gadgets and composed gadget. So we find out that we could do that by using spreadsheet. Spreadsheet, in each cell of this spreadsheet, we could put your defined one of the event. And so when you put all of these events, you must put them in some temporal ordering. So why temporal ordering? That will define how the gadget will work. So that's another analogy, like Geppetto used these strips, to move the Geppetto. So here we will put the events in some ordering, how they will perform during the execution this composite gadget. And we define this temporal two-dimension, which say that time is going, from up to down or from left to the right. We can do any of these, shapes. Within each sequence, well, if two neighboring cells, occupied, these two events are performed in order. So the whole workspace is split in event sequences which are temporally independent. Each sequence has its local time, which is aligned with the cells within each cell. So here, this sequence has ticks from A1, A2, A3, A4, and A5. Well, there are some events, like we could, control this local clock by setting, unconditionally, which will force this sequence to loop, indefinitely. And we can use conditional events for conditionally, so you can conditionally set that local clock if here is stated if results of executing this event in A12 is true, then this event in cell C12 will not be executed. Okay, so now we have idea how the events are ordered in time within spreadsheet. So how we look, that our composite gadget. So it starts with a get best offer. That is from our composed gadget start button. What will happen is that, first of all, the book title, which we'll type in that composed gadget here. So these are events, what will be booked. This will, what we typed in as a book title at my books, that is composed gadget, will be transferred to the book title of foo books. That will be retyped and transferred here. So the next one will be that will be transferred, the same parameter will to the bar books, and then we will perform get price event at foo books and get price event at bar books, and then the results of that execution, that price which goes from foo books will go to the first price at best offer. It will be transferred to this one. And the second one price, and then we will have event get best offer from best offer gadget. And at the end, we will transfer these results to our composed gadget. So this is how that will look sequentially. But if you have more experience, programmer or end user, you can rearrange these events and put these two events, split get price and get price at foo books and bar books in separate sequences, which means here that that will be executed in parallel, which means that will reduce the response time. So you can actually very nicely program the parallel or concurrent events by splitting them in separate sequences. So now we have our composed gadget is ready for use, which means that you can just type once the title of the book, and then you can find out the best price, and it will be executed like all existing gadget. So we started with gadgets as just user interfaces to services. But what we find out after research we did, that gadgets are not just user interfaces. Gadgets are the top level basic building blocks of distributed applications. It starts from object, component, services, and on top of that, you have gadgets. So gadgets are something which is atop on a service-oriented architecture. So to smooth, the transition from gadget composition to service composition, what we want to present here is human-centered and spreadsheet-oriented service composition environment, which we call HUSKY. What means that here we let's say the event sequence which is defined in spreadsheet on the top level, which we call gadget composition, is translated into spreadsheet which defined the service-oriented execution of this gadget. And a year ago, I presented two languages. One is this one, simple service composition language, which is script language, which is used for service composition. And another is, oops, I'm sorry on that. Another is Python, which is extension of Python language with the libraries, which enables to write very efficient service composition operations like communication and like synchronization and etc. Okay, so let me explain how this will go step by step. These gadget composition events will translate it into the service composition. So here we have Blue Fairy, which brought Pinocchio to the life. Actually, service composition bring our gadget composition to life by executing in distributed environment. Okay, so although this relationship between gadgets and services could be complex and sophisticated, for the beginning we will assume that behind each gadget there will be just one service. So let's imagine that behind FooBooks is service, which is defined at this page, foobooks.com page, which perform this logic of that gadget. And what will happen here that this get price event at gadget will be turned into the get price operation, which is executed on A1, and A1 is service definition. So we here see that beside events, we have service definitions as well as part of our spreadsheet, what we put in our spreadsheet. So at the same, we have service behind bar books, and this event is turned into the execution of operation get price on a service which is defined in A2 cell. So we have as well for best offer service, and we have event which is execute operation at service defined in A3 cell and operation get best offer. So beside these services, in order to perform in distributed environment, we need some additional services. One of these is input service, which provide mechanisms for typing in the book title. So this service is not, we could not see that on gadget level, but this is actually what we need in order to run that gadget. So what will happen here is that we will execute input to enable typing in the title, and then we need third one. We have another kind of services which is not visible. These services will enable communication between these event sequences which are temporarily independent. So one of these mechanisms could be queue. And what will happen after execution on A2, E2 service execute, after execution of this, E2 cell will actually have the value of book title. So we need to transfer this book title to the services, bar books and foo books. So we will transfer that through these queues. So we will first of all put whatever is result in E2 to C4, and C4 is a queue. And the same time we will put the same one title to another queue. Here we should first of all get that book title, so get from C4, and then we should use that as a parameter when we ask what the price of this book is. The same is on the other side. We should get the title of the book from G4 and then execute it, like after execution the event in G6, that G6 will have value of the title. So we need another queue to communicate between these two sequences and the last one. So we must put the results of execution of these get prices, which will be the prices, and put that in the queue defined in E8. And then we could use that two prices and start execution that service, which use that two parameters and choose the best offer, which could then be transferred to the hour as results through that output service. So we go through step by step, and now we have something which is fully defined in service-oriented architecture. So now we actually have tool which translate that in Python code, which could be executed in distributed environment. Well, there are some other communication mechanisms like clipboard. It's here efficient to use clipboard because you can just put the value in clipboard once, which will replace the old one. But what is nice, you can read it multiple times. But now, if you use clipboard, you must synchronize these two sequences. We will use token center, which actually contains some number of tokens. If there is no tokens, like here, we initially put 0 tokens, we will guard the execution of these two sequences by get token. So if there is no token, the sequences will not be able to execute. And that the last return token puts two tokens in that token center, which will then enable the execution of all of this gadget. There are another kind of services we can use. One of them is broker center. Here we have gadgets which are user-driven. So user is typing in and typing the start button to find out the results. Here in broker center will be event-driven. So this will be done by events. Here the broker center is publish subscribe mechanism, which we extend with the third party in communication. These are brokers. Brokers are custom designed services which, you know, the subscribers send some kind of announcement, and publishers publish announcements, and subscribers, you know, subscribe with terms. So the broker center analyzes what is announced according to the terms, and if this announcement satisfies the terms, then it triggers the execution of the sequence. So here up we have two publishers, one subscriber, and one service as a broker service. So here that gadget will provide new prices each time it changes. Even you can put what prices are you interested in. So there is no need for user to do this stuff. So, okay, let's go back to our previous first example. And now is question how this will be executed in distributed environment. Okay, so here, as we all know that we all know about coordination-based architecture. It has two functional elements. It has computation elements and coordination elements. So we extend this architecture to have three tiers. We have interaction elements as well, and these interaction elements, they provide communication, synchronization, and other mechanisms. So here, if we see that Geppetto, our gadget, has three types of functional elements. These event sequence are actually coordination elements. We have this queue, which are interaction elements. At the end, we have services, which are computation elements. So to execute this in distributed environments, we must somehow schedule these functional elements to the host machines of the distributed systems. In order to do that, first of all, we must map these elements to the services, and then services are scheduled to the host machines of the distributed systems. Here, there is no restriction how you schedule service to host machines, but mostly nowadays, service composition architecture constraint how can you map these functional elements to the services. Okay, there are three well-known architectures, one based on orchestration, another on choreography, and the last ones are multi-agent systems. So in orchestration, all interaction and coordination elements are mapped to the single service which coordinates the activities of these computation services. And that is how it's restricted in orchestration. However, in multi-agent system, these interaction elements are separate in separate services, and in coordination and computation elements constitute autonomous engines. However, in choreography, these interaction elements are part of communicating services, and this is how it's restricted. So we think that the best way will be there is no restriction. So we can map all of these services, all of functional elements to separate services. So since all other architectures constrain elements to service mapping, while this new architecture does not have any constraints, so the best results for our architecture cannot be worse than the best results for any other architecture. And we run some experiments with different applications, and we measure the execution time of this application. Here is one of these applications. It's just pattern. It models pattern producer, performers, and consumer. Okay? So if we now put that in the graph where we show how the number of host machines affect the execution time of distributed application, okay, we find out that two things. Since that we could, our architecture provides more flexibility than other architecture. So for any given number of host machines, our architecture will give much better results than other architecture. And another key point is that since we could, each function element scheduled to separate, it's mapped to the separate service and can be scheduled to a separate machine, then we could distribute it, the definition of gadget to the most, more machines than other architecture could do, which could do additional increase in performance. What we did up to now is that we have PI, which stands for Programmable Internet Environment tool. And you can, on this page, you can access this tool and use this tool, which translates this simple service composition language into the CL language. This we called competition language, which is actually the mix between, it uses two languages. It is BPL language and WSDL language to enable mobility of our coordination elements. And we interpreted this C language by translating in C#. Another tool, what we built is a HUSKY tool, which could be accessed from this page, which translates this HUSKY spreadsheet into the Python. Python is extension of Python language. It has a special library which enables that send, receive message, all of these operations to do very efficiently. Okay, and we are pretty end of this presentation. So what we present here is HUSKY is end-user environment which enable very efficient composition of services into the personalized web processes. And it is the first one system based on spreadsheet. And we add dimension, time dimension to spreadsheet, which enable intuitive expression of concurrency and non-determinism. We defined a new three-tier service composition architecture, which provides more granularity and which enable flexibility in scheduling of function elements to the host machines, which increases both performance and scalability. And what is more important is that it's a firm foundation for end-user gadget composition. And if you have end-user gadget composition, you actually can personalize gadgets for end users, and they can do that by themselves, which will increase the number of gadgets and the number of users. And this is very, it could be very interesting to see how new business models will show up with this gadget development, providing hosting and application. So it was very short what we did on this research. Now I am expecting some questions. I don't want to lose, much time of explaining how this works. If you have any questions, I will be very happy to answer you. Thank you very much.